Continuing from last time. Last time we did the most beautiful code quicksort with ternary partition, the simple one, and basically we used two loops over here, one over here and one over here, and those are very simple. So what I'm going to do now is I'm going to combine those two loops into just one and have a ternary partition here. Basically I'm going to use 3 pointers, less than the pivot value, equal to the pivot value, and more than the pivot value. Now the pivot value, this is actually just a variable that's going to choose randomly the values inside the list. This helps, so if the array is already sorted, it doesn't go into the worst case condition all the time. Now we have E is actually going to go through all the elements on the list, so kind of like an iterator, the I variable like last time. The low is basically the points to the lowest element, and the highest points to the highest element. And what happens is that as the iteration pointers going to the right, the less than pointer is going to the right also, but not at the same speed, only goes when the value is lower, and more than point value is going to the left and filling up this higher than pivot value, and they're going to meet in the middle over here, right here, and they're going to meet the middle. And when that happens, we're done. So let's go to the function, and the function here, quicksort, and low and high, basically that's just the range. Now I didn't put in anything else like the arrays or comparison function, but that's something you have to do yourself. This is the recursion termination condition. Basically, if high is less than or equal to low, return immediately. This is where we choose the pivot value, and basically we just put a random value anywhere between low and high, including. This is the loop. Now this is just one loop. Remember last time we do ternary partition and we used two loops. Now this is just one loop, but this loop is exactly the same as this loop right here, and it's less than, if the iteration with E is less than the pivot value, swap the element on the iterator to the one at the lower value and the P, and that's, I'm using P over here, and that's exactly what happens here if we set the initial pointers positions, and that's this one right here, 1, 2, 3, and then we check if the element in the iterator is less than P, then swap the elements, incrementing the less than pointer. But between those two lines, there's a command like while the array at the iterator is greater than pivot value, we swap it with the high, and with the more than value over here, decrementing the pointer. So that's basically decrementing this pointer that way. And we keep doing it until the iterator is more than the high pointer, which is the more than pointer. And that's it. And that's basically just 1, 2, 3. Just 3 lines over there. So, and you don't need to do anything else over here. You don't need to put some lines in the middle over here, because we already did ternary partition. The most important to note is that this is low and this is high, just like last time, but this one here is low, less than pointer and -1, offset 1, and this is more than pointer, offset 1. And that's very important. If you see two function calls like this using the same variable, that's probably not a ternary partition, no matter how complicated the top is. And that's it. And that's really beautiful, and it takes care of the worst case scenario, such as when the array is already sorted or the array having a narrow range of key. Now there's a Google video that shows basically the Quicksort was slow when it was doing a sawtooth data. When the data was shaped like this, it becomes slow. But that's not true. Because the data can be easily shaped like this, and it still be slow. What it is the narrowness of the key. Once the Quicksort partition this one, the rest of the values are identical, and binary partition will not take care of that. Binary partition will go directly into the worst case scenario, so that's not right. We're going to show the basic implementation right here real quick. That's the parameters S1 and S2. That's the termination condition. That's the setting up. That's the pivot value, just randomly choose from the arrays. This is the beginning of the loop. Now this one basic has a for loop, but it doesn't work the same way as C loops. C loops basically a while loop. This one doesn't have it either. So I'm using a label right here, M1. That's a label, and basically over here you see go to M1, and basically what does it just goes back to M1 over there, and that's a loop. That's the for loop. This is the while loop, and this is that final if comment right there. That's the final count. So that's just 1, 2, 3, and that's debugging to show the graph while it's being sorted. And that goes back to the M1, which is basically just loop. M3, this is where the pushing of the stack, setting up the parameters, and then do the function call, and that's slow, and L-1, and then pushing of the stack, setting up the parameters, and go do recursive call, and that's M+1 and high. And this is the end. Basically, you cannot just return the function immediately because you have variables in your stacks and you have to pop them up, and that's what this does. S equal to S-1, and then set up all the variables, low, high, pivot, less than, equal than, or more than, and that's the function. Let's see it in action. That's the function, and done. This is another one, and you can tell it works exactly like last time, but in this case we're doing a ternary partition, and the high is going. You remember that last time we bring the values from left to right. This time you're going to see the value being bring down from both sides, and it meets in the middle. See, it meets in the middle right there. It meets in the middle, and it's going to meet in the middle also. See that? So there's a pointer on the right and pointer on the left, and they're going to meet in the middle. There you go. See that? And that's Quicksort.